Hello everyone. Today we'll be starting a new chapter. So let us begin the chapter. We'll be starting the second chapter. So the name of the second chapter is whole numbers. So let us start. So in the introduction we'll be discussing what is the term called whole numbers. But before coming to whole numbers, we have to have some prerequisite knowledge, some basic knowledge about the different types of numbers that we have in mathematics. So let us begin. Now all the counting numbers starting from 1, 2, 3, 4, up to infinity are called natural numbers. We all know this. What are natural numbers? They are a collection of numbers that starts from 1 and goes up to infinity. They are also called counting numbers. Now when the number 0 is added to the collection of natural numbers, that is when the numbers start from 0, 1, 2, 3, 4 up to infinity, such a collection of numbers is called whole numbers. So in the previous point and this next point, the only difference that we can see here is the number 0. So 0 was not included before, now it is included. So whenever we include this 0 in the list of or the collection of natural numbers, then that collection of natural numbers changes its name to whole numbers. So I guess you got the definition now. What are whole numbers? Okay, so moving on. Now all the natural numbers are whole numbers, but all the whole numbers are not natural numbers. Now it seems to be a bit confusing, but it's not that confusing at all. It is very simple. If you read the line carefully, all the natural numbers are whole numbers, obviously. It's 1, 2, 3, 4, up to infinity. These are all included in whole numbers. But all the whole numbers are not natural numbers. Yes, this number 0, is it a natural number? No. So whole numbers, all the whole numbers, obviously these whole numbers are natural numbers, but this number 0 is not a natural number. So we cannot say that all the whole numbers are natural numbers. But yes, the opposite of that is all the natural numbers are whole numbers. These all numbers are natural numbers and these are as well whole numbers. Okay. Now moving on. 0 is the only whole number which is not a natural number. Yes, that makes the difference between whole numbers and natural numbers. The number 0. That is the only exceptional number which is making the difference between natural numbers and whole numbers. Other than that, there is no other major difference. So I hope you understood these points. Now moving on. Successor and predecessor. Now maybe you all have got some idea about these terms called successor and predecessor. You all have read in your smaller classes or in earlier classes that what is the number that comes before and after a given number. But maybe the term successor and predecessor was not used then. So these two terms are basically the same thing that you have learned earlier, that which number comes before or which number comes earlier. So let us have a look. Now successor of a number is the number which comes after that number. Say for example, the successor of 16 is 17. 17 comes after 16. So 17 will be the successor of 16. Clear? Now how can we get the successor? We can get the successor of a number just by adding 1 to it. We need to do nothing, just we have to add 1 plus 1 to it, to that given number, whichever number it is, just we have to add one number to it, and then we get the next number. Very simple. Now what is predecessor? It is just the opposite of successor. Successor is the number next to it, and what will be predecessor? The number before that given number. So the predecessor of 16 will be 17. And how can we, sorry, not 17, my mistake. The predecessor of 16 is 15. So how can we get 15? Obviously you got the answer just by subtracting. Before it was addition, now it is subtraction. To get the predecessor, we have to subtract 1 from that given number. So we got 15. 16 minus 1 is 15. Very simple. What is predecessor and successor? Now the whole number 0 has no predecessor. Yes. Does 0 has a predecessor? Now although some might think that the 0 has a predecessor, if we subtract minus 1 from it, then what do we get? The answer will be minus 1. But it is a negative number. And in this chapter we are not going to discuss those negative numbers. We will be only concerned with the whole numbers that starts from 0 up to infinity. So when we say the whole number 0, then there is no predecessor to it. Clear? Now moving on. Next is the number line. Now let us see what is the number line. A line on which the numbers are marked at intervals, which is used to illustrate simple numerical operations, is called a number line. Now this might not be very clear to you. So let us see a diagram. So this is a number line. As you can see, this is for whole numbers, not for any other numbers, just for whole numbers. So it starts from 0 and it goes on up to infinity. That's why this arrow mark is given here. It is similar to what you have learned in your earlier class, a ray. It has one end point and the other point it goes on up to infinity. It has no limit. Since it is whole number, so it will start from 0 and it goes to infinity. Now what does this definition says? That a line on which numbers are marked at intervals. This 0, 1, 1, 2, 2, 3. These are what? These are intervals. This gapping is the interval. Okay. And this gap has a particular name. What is this name called? Unit distance. This distance is called the unit distance. All these gaps or the intervals are called unit distance. So this gapping or the interval is fixed or it is constant. It's not that the gap between 3 and 4 is larger than 4 and 5 or 4 and 5 is smaller than 5 and 6. It's not like that. The gapping or the interval is at equal distance, or you can say constant. Now moving on. How can we apply the operations? So what are the operations? We have 4 basic operations: plus, minus, multiplication and division. These are the 4 operations. Now let us see how can we operate these operations on the number line. So addition, first of all let us see how to do addition on a number line. Say we are given a question, add 3 and 4 and represent the sum on a number line. We all know 3 plus 4 is 7, but how will you represent it on the number line? So let us see. So here, as you can see, we'll start from 3. Since the number given to us is 3, so we'll start from 3 and then we'll add. Now for addition, what to do is, the number which is given to us, we'll start from that point or that number, you can say. Then if it is add, we will move towards the right side. This is the right side and this is the left side. So we'll move towards the right side since it is add. Now how much places we will go? We'll go 4 places because we have added 4 to it. So if we start from this 3, we'll go to 1 place, 2 place, 3 place and 4 place. So this will be our required answer, that is 7. 4 jumps we have to make. After addition, the number which is given to us, we have to make that many jumps. And the previous number, that is 3, which is given to us, from there we have to start it. Clear? So, we also know what is the sum, that is 3 plus 4 is 7. So, whenever you have to represent such a sum, you have to represent in this manner. So, it makes a jump. This represents the jump. Clear? Now, moving on. Next is subtraction. How to do the subtraction? Say, one question is given, subtract 5 from 7 and represent the difference on a number line. So, here, it is just the opposite of addition. In addition, we were moving towards the right. Here, we are moving towards the left. And remember, don't forget to give this arrow symbols. This denotes the direction in which it is moving. So before we were moving from here to here, from left to the right, and now we are moving from right to the left. There is the difference between addition and subtraction. So we have to subtract 5. So obviously we know it is 7 minus 5. So we'll start from 7. Since we have to subtract 5 from 7. So we'll start from 7. Then we'll make how many jumps? 5 jumps. Since 5 is given. So 1, 2, 3, 4, 5. So we made 5 jumps, and wherever we came to a stop, that will be our required answer. That is, here in this case it is 2. Simple. Now, moving on then. The next operation is multiplication. How to do the multiplication? Say we are given a number, multiply 3 with 4 and represent the product on a number line. So this is the number line and this is the representation. Now here in this case, it is a little bit different. Here we will not start with 3 and jump 4 places, but instead we will start from 0. Okay. This is the unit distance, or this is the gap that we have to maintain, and this is the number of jumps. 4 is the number of jumps that we have to make. So keeping a gap of 3 units. This is the 1 unit, 2 unit, 3 unit. So this much gap we have to keep. And we'll start always from 0. So starting from 0, we make the first jump. Then keeping a gap of 3 units, we'll make the second jump. Again keeping a gap of 3 units, we'll make the third jump. Again keeping a gap of 3 units, we'll make the fourth jump. So that's it. After making the fourth jump, wherever it comes to a stop, that is our required answer. Clear? And we already know the product of 3 and 4 is 12. So now, basically, you might be thinking that what if there is a greater number? Basically, while representing on a number line, the numbers that are given to you are very simple numbers, single digit numbers. The answer might be a 2-digit number, but which are representable on a number line, those numbers will be given to you. It's not that a very large number will be given to you for representing. In that case, we will carry on with the normal multiplication. So, okay, that's it for today. Hope you all have understood what is whole number, what is natural number, how to use these numbers on a number line. So that's it for today. Thank you and have a nice day.